Okay, so I did just spend half an hour recording this and none of my audio recorded. So this may move quickly. Uh, I am expecting a pest control tech here in 20 minutes because I woke up to a squirrel having chewed a hole through the ceiling. So we're going to power through this. We're talking about states of matter and the kinetic molecular theory today. I have put in place a little bit of a break to pause so you don't do all of this in one go. And I will be talking about your assignment for the week as well, giving some clarification as we go. So let's start off. We're talking about the states of matter and kinetic molecular theory today. So, key concepts for our first half. Matter can be solid, liquid, or gas, and that matter is made of particles in constant motion. So we're going to be hitting these two concepts hard for this week. All right, so we have three main states of matter. We have liquid, which is our water there. We have a solid, which is our wood, and gas, which these balloons are filled with. Some key things, common characteristics. Solids hold their own shape. So wood is not very malleable. It's not changing shape on you. Has a constant volume, so is always taking up the same amount of space. And some examples at room temperature: wood, silver, stone, and plastic. Liquids take the shape of its container. And they have a constant volume. So by taking the shape of a container, if you put water into a glass, it's going to take the shape of that glass. And some examples at room temperature are oil, juice, antifreeze, and gasoline. Sorry about that. And I don't have great editing software, so you're welcome to my sneeze. Fun thing about gasoline, we just call it gas, but it's at room temperature not a gas. Types of gases, they take the shape and the volume of its container. So we're going to talk about why, but gases can be compressed. And at room temperature, we have things like the air that surrounds us, which is made up of several types of elements. We have helium, and we have hydrogen. Okay, there is a fourth state. So we're most familiar with solids, liquids, and gases. We deal with them every day. But actually, most matter in the universe exists as plasma. A plasma is similar to a gas in that it does not have a defined shape and volume, but plasmas have different electrical properties than gases. So we'll give you a few examples, and you'll kind of see what we mean by different electrical properties. So here's the sun. The sun is made up of gases and plasma. We also have a lightning bolt here. There's electricity involved with lightning, so that has to do a bit with that electrical property. And then we have a neon light where you put an electrical current through the neon plasma. Okay, so we're going to be using a model to explain everything with the states of matter and how they change. So we're just going to establish what is a model and what's a theory when we're talking about science. So a model is a verbal, so it could just be a statement, mathematical, a formula, or a visual, so like a drawing, illustration, representation of a scientific structure or process. So it's explaining something that we see. And a theory is a scientific explanation that's been supported by consistent, repeated experimental results and is therefore accepted by most scientists. So theories are supported by lots and lots of evidence. We do have some laws in science, but not many. And it's pretty difficult to make something scientific law. So we're going to use something called the particle model of matter to explain the states of matter. So the particle model of matter says that all matter is made up of very small particles. So using this model, scientists developed a theory to explain the behavior of gases. And this theory, when used to explain all states of matter, is called the kinetic molecular theory of matter. We're primarily just going to call it KMT because it's a lot easier to say. Oops. So an important part of KMT is kinetic energy, the kinetic portion of the kinetic molecular theory. And kinetic energy is the energy of motion. So anything that's moving has kinetic energy. According to KMT, all particles are constantly moving and therefore have kinetic energy. So KMT is able to successfully explain different states of matter and the ways in which matter changes states. So we're going to go through 4 points, 4 parts of kinetic molecular theory. In your assignment this week, you're going to be using those 4 parts, and you're going to be using images and explanations to describe them, and using the kinetic molecular theory to describe changes in states of matter. So let's start from the beginning. All matter is made up of very small particles. So here we have a solid, and it's rigid, has a fixed shape and a fixed volume. We can see that these particles are very close together, and they're only slightly moving, they're just vibrating. And this solid cannot be squashed. So if you think about your phone being a solid, you can't really squish that smaller, you just break it. Okay. Liquid, it's not rigid, there's no fixed shape, but there's a fixed volume. So they're still fairly close together, these particles, but a little bit more space, and they're able to move around a little bit more. They just kind of slip and slide past each other. This also cannot be squashed. So think if you got a glass of water and you push a lid further down, you just get water everywhere. You're not able to make it smaller. Gases, not rigid, no fixed shape, and no fixed volume. They can be squashed. So we see a lot more space. They're moving fairly freely, and they can be squashed because there is so much space in between. You can push those particles closer together. Number 2, the particles exist in empty space. So in solids, the particles are closely packed and held rigidly in place. In liquids, the particles are also closely packed, but they can move around. And in gases, particles have a large amounts of empty space between them and are not attracted to one another. So basically, there's just not a gravitational pull between them because they're too far apart. Number 3, particles are constantly moving. That's the kinetic portion of this. So the particles in solids, they vibrate but cannot move around. There's just not enough space. In liquids, the particles slip and slide past, and they revolve around each other, but they stay close together. They collide with each other and the walls of the container. The particles in gases move freely in straight lines. They collide with each other and with the walls of their container. And 4, energy makes particles move. So the more energy the particles have, the faster they can move and the farther they can get. So this would be a really good place to talk about phase change when you're doing your project. We'll talk about that more though. So our states of matter, there's these fundamental differences that have to primarily do with the distance between particles. So if we start with a gas here, if we cool it or squash it, increase the pressure, we end up with a liquid. Cooling is actually the same thing as saying we're removing energy, removing heat. If for that liquid we cool it, we end up with a solid. If we do the opposite, we start at a solid and we add heat, we end up with the liquid. If we reduce the pressure, give more space, and heat, we could end up with a gas. So this is a time for a pause. So if you're feeling like, oh, that was a lot of talking, take a break. And when you're up for it, the other half will await you. But I'm going to move on. So for the second half, we have two more key concepts. Number one, changes in state result from changes in particle motion. And number two, the kinetic molecular theory explains physical changes and properties. So essentially, we're going to give more explanation to the last slide that we looked at. Okay. So sometimes we call changes of states phase changes. It just sounds cooler. I'm sure that's not the full reason, but that's the reason I'm giving you. So most pure substances can exist in all three states, depending on temperature and pressure. And a few substances, such as water, exist in all three states under ordinary conditions on Earth. So frequently we use water as an example because we can see water as a solid, say in ice cubes, as a liquid, we drink it, or as a gas when you see steam, boiling water. And we can all see all of that in one day in our life. So we like to use that as an example because it's something that people all have some context for. So we have 6 different phase changes. 4 of them you're probably familiar with, 2 a little bit different. So let's start down at the bottom and move clockwise. So when we have a gas going to a liquid, we call that condensation. So that's, say, the morning dew on grass. And when we have a liquid going to a gas, we call that evaporation. So think about that steam that is coming off when you boil water. Going from a liquid to a solid, we call that freezing. Sometimes people call it solidification, but I find it's easier to remember freezing because you can think about putting water in an ice cube tray and ending up with ice. And then a solid going to a liquid, we call that melting. Now the ones that you may not be familiar with and are more difficult to find examples of, when a solid goes directly to being a gas, does not become a liquid in between, is sublimation, and a gas going directly to being a solid without a liquid in between is deposition. Okay. So we get changes of state by adding or removing energy to matter. So this addition or subtraction of energy changes the temperature of the matter. Temperature is a measure of the average kinetic energy of the particles in a substance. So that energy that we're adding or taking away is heat. Increasing the temperature of matter means the particles of the matter are gaining energy. So we talked about melting point and boiling point last week as being physical properties of matter. The melting point is simply the temperature at which a substance melts. So for water, that's 0 degrees Celsius. The temperature at which a substance boils is called its boiling point. For water, that's 100 degrees Celsius. And we can use these to actually identify what a pure substance is, or which pure substance sample of matter is. So let's kind of go through the addition or subtraction of energy. So as heat is applied to a solid, the molecules gain energy and start to move faster. And the space between molecules increases. So we're following these red arrows. We have a solid, we're adding energy, they're moving faster. There's more space, becomes a liquid. If we continue to add that energy or heat, that liquid will then become a gas. it's moving even more, there's further space. Now, conversely, if we follow these blue arrows, we're removing heat, we're cooling the matter, and we lose energy, move slower, and the space between the molecules decreases. And that's where we get a gas turning into a liquid. If we continue to decrease that temperature, remove that energy, we get less space, less movement, and that liquid becomes a solid. Okay, so that's basically the idea between kinetic molecular theory and things going from solid, liquid to gas. Oops. So I'm hoping that by the time you're watching this, I'll have a little demo of diffusion up as well. We also just had our dishwasher break, and we're installing, and we've just removed the dishwasher and we're installing a new one right now, but we both have to work all day. So once that's sorted, I'll get in the kitchen and I'll do this this demo for you. It's been a wild week. So the kinetic molecular theory can also be used to explain other physical changes as well as physical properties. And one of them is diffusion. So it's the movement of one material through another. So the example that we're using is what happens when we basically are putting sugar into water or into a liquid. So what happens is we end up having the sugar molecules breaking off from that sugar cube, and we're getting more space between those sugar molecules. And as more and more sugar molecules move away and randomly bounce around, we see all of them evenly distributed through the water. And we end up with just a liquid. We don't have a bit of solid and liquid. We just have our sugar water liquid there. Another thing that can be explained is something called thermal expansion. So solids, liquids, and gases normally expand when they're heated, and they contract when they're cooled. So they get bigger when they're heated, smaller when they're cooled, which makes sense because we have either an increase in the space between particles or a decrease in the space between particles. So this means that the hotter that most substances get, the more their volume increases. The colder they get, the smaller their volume. And the expansion of heated materials is called thermal expansion. Thermal just means it has to do with temperature and heat. So solids, so if you heat a solid, increases the kinetic energy of its particles, which causes them to move faster. And this increase in the vibration causes the particles to move slightly further apart, and the material as a whole expands. In liquids, they expand more than solids because their particles move more freely and can move further apart from one another. So one of the things that we'll see as we get the heating and the cooling, when we have our temperatures in the winter fluctuate, is we get some liquid going in between the asphalt on our roads. And it'll freeze, it'll contract, and then it'll thaw and it'll expand. And what we end up with is our beautiful potholes, because it'll kind of, that thaw and freeze will end up breaking down all that asphalt. So we can actually explain our awful potholes here using science or kinetic molecular theory. Gases. So key thing about gases is that they can expand indefinitely, but gases heated in rigid containers cannot expand more than the walls of their containers allow. So we talked about compressed gases when we talked about our hazard symbols. So if you've ever seen anybody who needs an oxygen tank, that's a compressed gas. Some of our household products also come in these rigid containers. Aerosols, they're compressed gases. So these particles collide with greater and greater force as they're heated with the container walls, which means that the pressure on the inside of the container increases. So if the pressure becomes great enough, the container will end up exploding. It's not a good thing. All right, so I'm going to just show you your assignment here. So you're going to create a poster either physically on paper, submit it as a photo, or digitally. It could be an online document on Word, PowerPoint. You can make a video. I'm open to many different methods, but essentially you're going to create something where you could teach somebody else about the kinetic molecular theory. You're going to describe each of the 4 points of the kinetic molecular theory, and you're going to include images explaining. And you're going to use kinetic molecular theory to explain each phase change. So we're talking about the addition and subtraction of energy, and you're going to use images for that. So this is due next Monday, April 27th, and you will have pages 134, 144 in the textbook are the ones to refer to. You do have the online access to that if you don't have your textbook. I'm going to leave you there, and I hope I have some more information about communicating with me coming to you in your emails. Have a great day.